Um, Hi, everyone. Welcome to this training session brought to you by the Society of American Archivists and the Archivists of Religious Collections section. My name is Sarah Waits, and I am in New Orleans, which was historically known as Bolbancha. In the Choctaw language, Bolbancha means the land of many tongues. And this represents the traditional homelands of numerous indigenous nations, including the Choctaw, Homa, Chitimacha, Biloxi, Tunica, Atakapa, and the Natchez peoples. Today's topic is Introduction to OpenRefine. Before I introduce our presenter, let's go ahead and review the disclaimer. So I'm going to read this out to you guys. The content in these presentations is for information only and is not legal advice. Our views do not represent the organizations where we work. We do not make any endorsements or guarantees. We are not liable for any loss or damage caused by your use of the content we provide. It is your responsibility to critically evaluate the content provided in the presentation or any accompanying materials. Welcome to our Lunch and Learn. Please mute your microphone and turn off your video. You can click on the closed captioning button to get closed captioning under the More button. There will be a question period after the presentation concludes. Please use the Q&A feature under the More button on Zoom to ask your questions during the question period. We will not be monitoring the chat. Please be respectful in your interactions. We expect you to follow the SAA Code of Conduct, which you can find on the website. This session will be recorded, and it will be available on our YouTube channel within 2 weeks. And we encourage you to join the Society of American Archivists if you are not already a member. And now I would like to introduce our presenter, Erin Greeno. Erin Greeno is the Digital Archive Systems Lead for the United Church of Canada Archives in Toronto. Her responsibilities include managing the United Church of Canada Multi-Repository Descriptive Catalogue and the Digital Preservation Program. She has extensive experience using OpenRefine to migrate legacy data to current systems. Erin holds an MIST from University of Toronto and has been a certified digital archive specialist since 2020. And Erin, I'm going to turn it over to you.
Okay, just great. Just hold on a second here. I'm having some issues with my screens. Okay, I think that looks right. Thank you everyone for coming today. Today I'm going to be talking about OpenRefine. There are a few points I wanted to make before diving into what is OpenRefine and how archivists can use the tool to clean archival data. So firstly, I'm not an expert on OpenRefine. I am simply an archivist that often needs to migrate messy data into new archival systems. And I've had to rely heavily on OpenRefine as a tool to help with that work. So the more that I have used OpenRefine, the more I've become its champion. I regularly encourage others in the profession to use OpenRefine, and this workshop seems like a perfect opportunity to advocate for the usefulness of OpenRefine. So I will be approaching the workshop from the perspective of an archivist with messy data. So perhaps with limited resources and time and with limited to no knowledge of scripting language. Secondly, there is no one way of using OpenRefine to clean data. So today I'll be showing some of the core functions of the tool and some approaches to cleaning data. But if you decide to use OpenRefine in your work, you can approach cleaning in the way that best suits your goals and your workflows. So today I will be providing a brief overview of OpenRefine, its history and key strengths. I will describe how OpenRefine can help with archival work, and then we will go through some transformations together to clean data within OpenRefine. And during that process, I will introduce you to using GRIL, which is the general refined expression language used within OpenRefine. So at the end, I will very briefly touch on the reconciliation opportunities with the tool, and hopefully we'll have time at the end for questions and or discussion. So OpenRefine is a free open source application designed to explore, clean, and transform data. So originally the tool was designed in 2010 for Freebase, which was an online knowledge repository. So shortly after its development, Google purchased Freebase along with its data cleaning tool, which was then renamed Google Refine. So 2 years later, in October 2012, the Google Refine application was transferred to the open source community and rebranded as OpenRefine to reflect its community-driven status. The user community continues to grow as the tool expands its functionality. Users include data scientists, journalists, researchers, and GLAM professionals. In a 2024 user study, OpenRefine discovered that 34% of OpenRefine users were actually librarians, and 25 were from the art and heritage sector. So archivists were not defined as a specific user base, but I think it's safe to say that many archivists are included along with those librarians and heritage professionals, and for good reason. OpenRefine is an excellent tool to clean messy data, which archivists are all too familiar with. So OpenRefine is a power tool specifically for working with messy data. It's literally the slogan for OpenRefine. In the upcoming slides, you will have an opportunity to see what OpenRefine looks like and how it can be used in archives. But before we jump into the nuts and bolts of the tool, I wanted to give you an idea of why it may be worth your while as archivists to explore OpenRefine. So in our work, messy data just exists, and we often need to clean it. We may have archival descriptions that are not in accordance with descriptive standards. Legacy descriptions may use institutional specific fields that need to be mapped to archival description standards, or even when descriptive standards exist, staff over the years may have approached descriptions inconsistently. So archives frequently inherit descriptive data that contains inconsistent creator names, subject headings. There's a common problem of having varying date formats used, or dates may have been changed in Microsoft Excel when importing or exporting data. There may be terminology that no longer aligns with current standards and need to just be edited. And there's just also typos and duplicates in our databases and spreadsheets that affect discovery. So OpenRefine offers an opportunity to review and evaluate the data in a more visual and forgiving way than, say, looking just at spreadsheets. Through filters, facets, and clusters, data can be grouped by similar values, so we can edit them in a preferred way. Specific errors such as misspellings, extra spaces, or invalid dates can be identified and corrected easily. One great feature is that information within one field or one column can be batch separated into single columns. And so, for instance, perhaps you have a note field that contains many different types of notes that need to be separated into the unique note elements listed in Rules for Archival Description, or DACS. And that can be done in OpenRefine. And lastly, one of OpenRefine's most valuable features is entity reconciliations. So archivists can match name, places, and subjects against external authority sources, such as Library of Congress, VF, or Wikidata. So as I go through this presentation, I invite you to consider these benefits and how OpenRefine could help your institution's work. So the interface of OpenRefined is very, oops, sorry, I jumped ahead there. OpenRefine is an appealing and accessible tool that any archives can use as long as you have access to a computer. So firstly, it's a free open source tool. There's no upfront costs, no subscriptions. So it's a tool that archives can use without worrying about any budgetary restraints. The tool has existed for 16 years, making it a mature and stable platform. It has a very active GitHub community with hundreds of contributors, and there's regular releases and updates. The tool can work with Windows, Mac, and Linux operating systems and can be easily downloaded from the website openrefine.org. So OpenRefine runs a small Java-based server on your computer. So once downloaded, OpenRefine opens in your default web browser using port 3333 of your local computer. And it's important to note that it's not actually a web application. So you do not need internet access to use most of the functions of the tool. And most importantly, when using OpenRefine, your data is not being stored online. And so there's no risk that any of the data that you are working with will be shared, used, or misused by others. Instead, data projects created in OpenRefine will be stored in local workspace directories on your computer. And you do have the option of sharing OpenRefine projects through exports. So it can still be a collaborative tool if you need to share it. So the interface of the OpenRefine is very basic and easy to navigate. As shown in the slide, you can see the left sidebar which lists the available actions. So the create project, open project, and import project. There is also an opportunity, if needed, to select language settings and to define and to connect to any available extensions. So, but what is a project? So in OpenRefine, a project is a self-contained workspace that stores an imported data set together with its transformation history and data cleaning operations. It is important to stress that OpenRefine does not change the data from the original file that was imported. So at import, a new file is created in OpenRefine, and that file will then contain the contents of the original file, as well as a history of all the changes that you make to the dataset over time. Once the data has been fully cleaned, you are able to export the project in the format of your choice. And then at the end, you have the original file and the new clean file. So data can be imported from many formats, some of which may be of common use at your archives. So that includes tabular data formats like TSVs and CSVs, Excel spreadsheets, LibreOffice ODS files, and Google Sheets. But you can also use data from formats like JSON, XML, and RDF data saved as XML. So for those of you who may have data saved in MARC format, those data files will need to be extracted and exported as a file format supported by OpenRefine, or you can actually export to OpenRefine directly from within the MARC Edit software. So to create a project, you just need to choose the file that you want to work with from your directory. Or in newer versions of OpenRefine, the file can be dragged to that box that you see in the middle of the page. Once the file is selected, OpenRefine opens to a configuration page as shown in this screenshot. So this page provides an example of how the tabular data will be represented in the new OpenRefine project. It allows you to quickly identify any configuration errors. And so, for instance, if I was trying to open a CSV, but it's set to separate columns by tab, you would see rows that would include all the data instead of having it parsed into many columns. So you can then select the right separator to make sure your data is represented correctly before you open the project. It also gives you an opportunity to select certain parameters. And I think many of us will be working with CSVs or spreadsheets, so I will just focus on those configurations. So for CSVs and spreadsheets, the default setting parses the first row as the title row. And if your spreadsheet or CSV does not include a title row, then this feature must be toggled off. Otherwise, the first row of the data will be named as titles, and then the data within that row can no longer be workable. There are also options to store or not to store blank rows, whether to store blank cells as null. There's also an option to import all cells as text. So once everything is configured properly for your project, you can rename the project in the right-hand corner, just right over here. And if necessary, then create a project. So right now I'm just going to stop sharing my slides, and I'm going to open up OpenRefine so we can work through um, the program together. So just give me 1 second. Okay, so you should be able to see the screen now. Yeah, okay, perfect. Um, so let me just get my notes open here. So this is a project example of a project that I had worked on with the United Church of Canada when we migrated 50,000 item level photograph descriptions from our legacy software into our access to memory or ATOM instance. So for convenience sake, this is just a small sample of that. But I should say that there is no limit to the size of the data set that can be open in OpenRefine. You can easily work with tens or hundreds of thousands of rows with little problem. However, I've noticed that if you're making a lot of changes to the data, the tool becomes slower and slower. As you go and the more transformations that you make. So you should just keep that in mind when planning any data cleaning project. So at first glance, the project looks very much like any other spreadsheet that we work with. There's the rows, the columns, and then the individual cells. Let me just move that over there. So at the top left corner, you'll see here, you can rename the project at any point by just clicking on that. We're not going to do that right now. And you can, yeah, just edit that at any point. At the top left corner, on the left sidebar, you'll see that area where the facets and filters for the work that we will be doing will be shown right here. You will have an opportunity to see how that will look later on as we do start to do some transformations. There's also a tab right here called Undo Redo, which shows the changes made to the project over time. So a key advantage of OpenRefine is that it's a comprehensive audit trail. So the tool is self-documenting. So every action performed in a project is automatically recorded in the project's history. So this includes any edits or transformations. So having this tool right here allows for full transparency of the work that you're doing, and it also allows you to undo or review changes at any point. You can go back and forth between actions if need be. There's also the opportunity to save actions to be used on other similar projects. You can just go to extract here. You can select what actions you may want to capture, and it will be saved as a JSON file, which then you can export. It will be downloaded to your computer, and then you can apply that same action set to additional projects if the same actions need to happen for various different projects. There's also the data that we'll be working with, which is the bulk right here of what we see. OpenRefine allows you to set the number of records that can be seen. So anywhere from 5 to 1,000. I've selected 25 just to fill the screen. And there's also the option to view records and also rows. So ideally, the number of records and rows should be equal. However, there's cases when data for an entity um, may have several rows in a spreadsheet, and the number of rows will be greater than the number of records when it's imported into OpenRefine, as we can see here in this project. So there's 5 more rows, and we will actually go back to this scenario and correct that, but we'll just fix that later. So how do we clean the data now that it's in OpenRefine? So columns in OpenRefine serve as the primary structure for organizing, cleaning, and analyzing data. Therefore, actions or transformations are mostly done at or within the column, and each column has the same drop-down menu. So each column here is the same across the board. A very simple feature of OpenRefine is filtering. So you can go here and select text filter. This looks familiar. It's similar to other software that we use. I'm going to select Glenna in the filter, and then you'll see that all the instances, so all the rows or all the descriptions in this case, for the Glenna Jameson collection appears. So you are able to select whether or not it can, your filter is case sensitive. I usually don't, because this is a great opportunity to identify any errors in capitalization. You can also filter by regular expression, but we're not going to go into that today. So the feature that really stands out for OpenRefined is the facet function, which is available right here at the top. So this allows OpenRefine to group records according to their values or characteristics. And you can facet columns in a number of different ways. So you can facet by text, by number, timeline, scatter plot, and then there's a whole bunch of other customized facets. So it's a very useful tool. The facet that you will use most frequently as archivists is the text facet. So I just selected the text facet to this column that's named collection. And you'll see that all of the different instances within that column is then listed here. So text facets are strings, so every character matters. And so you'll see here that it's capturing different facets because of some variances within those strings. So facets can be organized alphabetically, or it can be organized by count. You may want to use count to determine, a number of descriptions for a particular collection. It could also be handy to compile statistics or to support strategic planning at your institution. So this is, I use count often when I'm just analyzing the data. So I'll go back to name. So using text facets is a great way to analyze data and to identify obvious errors. So for instance, here you can see that the Toronto Churches and Institutions photo collection has a number of variations. Here you'll see that photographs is not capitalized. And then also that there is an S. So that is just entirely wrong. And then over here, there's no obvious variation, but it's most likely that there's an extra space at the end or somewhere within the string. So you can correct the collection name just within the sidebar here. So for instance, I want to remove that extra space. I'm going to go back to the N, and then I'm going to apply it. So that's a really easy way of working, editing, using facets, but that's only if there is like smaller data sets. Sometimes there's just too much that was faceted and it can be overwhelming. Also here, you can actually click on this one. We know this is problematic. And so this is, it's now filtered all of those instances, and we can actually correct the values by hovering over the edit button here on the actual cell. We're going to change that P to a capital, and we're going to remove that S. And then because there's more than one instance, you can actually apply to all identical cells. I usually apply to all if I know that, even if I don't know if there's other instances, just because if it's supposed to be a certain way, then you might as well apply it to all. So for the purpose of this demonstration, I'm just going to go back so that we have those variations again. I think, yeah, there it is. Okay. So another way of grouping data within OpenRefine is through clusters. And clustering is a way to group values that are similar enough that they may represent the same thing, but are spelled or formatted differently. So I'm just going to show you where clusters are. It's in the drop-down. You go to Edit Cells, and then to Cluster and Edit here. So that opens up a new box. So earlier on, I was having a lot of difficulty getting out of that box. So let me just see if I can, there. Okay, that's better. So the cluster allows you to configure various options for clustering. There's different methods and keying functions. I'm not going to go into those various options today, but the OpenRefine documentation on clusters has comprehensive definitions that can better explain it than I ever could. So for this demonstration, I'm using function metaphone 3, and then I'm going to select cluster. What? Oh, my apologies. That's because I'm only focused on those filters. So that's an important thing too. Sometimes when you're doing actions, you have to kind of double check to make sure that you don't have certain filters selected, especially if you're working with a whole data column within a data set. So let's do that again. Go to Edit Cells and Cluster. We're going to select Metaphone 3 and then select Cluster. So here you see it has identified the different variations of the Toronto Churches and Institutions photo collection. It also has offered a new cell value. So in this case, it has selected the term or the phrase that has the most instances. But if you wanted to even change that, you can go in here and edit that. You can select all of the changes to a specific cluster, or if you wanted to, you can just select one or two within the cluster. So I should note here that it has identified two collections that have the United Church of Canada in the title, and these are obviously not the same value, so we're just going to leave them unselected. So if there was many more cluster options, we could merge and recluster multiple times. But since this is a small data set, we'll just select merge selected and close now. And then you can see over here in our facet that we only have one now version of Toronto Church's photo collection. Now, this was a very simple example to demonstrate clustering, but for such a small data set, I probably would not have used clustering to edit those variations. But if I go over here to the column PD, which is physical description, and do the same, go to Edit Cells, Cluster and Edit, and then Cluster, you'll see that there's many more options. And this time, the clusters have identified like certain nuances such as periods, spacing, etc., that may take longer to identify and edit just by looking at facets. So there's a lot of ways that you can use clusters. So edits to data can also occur through common transformations. Um, So let's just show you where that is. So under Edit Cells, you have a list of common transformations that have been programmed directly into OpenRefine so that you can use them. Some useful ones that are very hard to identify by just looking at the data are trimming white space and collapsing any consecutive white space. So I know I have a habit of typing space after a word, and that extra space may not translate well when importing data into a new system. So for instance, in access to memory or Atom, if there is an extra space after a subject term, it creates a brand new subject term in the subject taxonomy. And you don't want to have to clean all that up within Atom. So you just need to get rid of that dead or extra space. And I usually run these two transformations for every column early into the data cleaning project, just because it kind of takes away those obvious errors and you're working with a more like a cleaner data set. Um, so I'm just going to run this one, which is the collapse consecutive white space. And you'll see up here that there has been 42 columns here that have been modified. And I'm not going to facet it to show you that because there's just too many options. So you're just going to have to trust me. Another very useful common transformation is unescaping HTML entities. So you know those random subjects, well, not random, I guess, just the series of symbols and characters that appear in words that represent accents or other special characters in HTML. I'm just going to show you an example here. So you see, oh, I must have cleaned it up by accident. So you're going to have to trust me that Montreal at one point had a whole bunch of characters right here. And if you select the common transformation unescape HTML entities, then it will automatically take those characters, those HTML characters, and then turn it into the proper accented E for Montreal. So my apologies that for whatever reason that's not showing up right. Another common transformation include changing case of values to upper, lower, or title case. You can transform curly quotes. Let's see. I'll just pull this up so you can see the different ones. You can replace, yeah, like I said, smart quotes. You can change the cells of a column to number, to date, or to text. To date will automatically format any dates into month, date, and time format. So if that's the way that you need it to be formatted, then that's great. But you can do more precise conversion and formatting using GREL language and transformations. So I'm going to go back to the collection here, the collection column. So we had discussed earlier that there may be more rows than columns. Hold on a second here. Don't want to have too many boxes open on the side. And the project example has 5 extra rows. So if you look at the collection facet, you'll see at the end that there are 5 blanks. So you scroll over and you'll find some orphan physical descriptions. And we don't want these descriptions to be isolated. We want them to be part of their archival description. And so the way to do that is to go to Edit Cells. And then down here, there's a tool called Join Multi-Valued Cells. So once that is selected, you can indicate what the separator will be. I'm using a pipe or a vertical bar, and then you select OK. So you can see, again, because this particular column, there's so many different variations, I'm not going to facet to show it to you, but you'll see over here that that blank line in the collection facet is gone. So there's no longer any of those orphan, physical descriptions, and the records should now be the same as the rows. So you can also split entities to create separate rows, and I don't personally know when you might want to do that, but I'm sure it may have a good use for someone. Um, so we have shown the common the common transformations that are built into OpenRefine that handle the common cleanup issues. However, a lot of the time, data cleaning involves very specific changes to the textual information in the cells. So we need to work with, personal transformations. So for instance, you may need to add characters to specific cells or all cells within a column. So in this example, the descriptions are for photographs. Um, and you can see here that each photograph has an accession and an item. At the United Church, we always add a P to represent photographs to the end of an accession number, and the P does not exist in this data set, and we need to add the P. So let's look at how we can do that in accessions. Now, first, I just wanted to know that this column is our accessions are numerical, and sometimes during an export using Excel or CSV, then numbers can change. So I'm just going to really quickly do a text facet. And I'm going to scroll down to see if there's any obvious issues. And you can see here that the accession number 2013.2 is missing two numbers. So we can change it right in here. And now just by sight, you can see that it should be okay. Also, there is a way that you can facet by word length. I'm not going to go into that because I am a little worried about time. But there is a lot of cool ways of like identifying, whether or not there's missing integers in the numbers. So to add the P, to do the simple transformation, we're going to go to Edit Cells and then to Transform. Once that opens, you'll see that this is like the custom transformation box for text. It's really great because you can see here that there is a preview button and it shows you the current value here. And then here on the right-hand column, it will show you what the changes will be once you've added an expression to or a transformation. So there's also this opportunity here to look at the histories of certain things that you've done in the past, and that maybe you can borrow that expression for this particular transformation. So here in the expression box, I'll just hold on a second. The transformations that we use within OpenRefine uses GREL, which is the general refined expression language. You can, if you have the skill set, also use Python or Clojure. But general refined expression language is quite easy to use. So it's a simple scripting language designed for easily managing values with OpenRefined. And don't let that scare you, especially for those that are not familiar with scripting. But I assure you that once you start using some of the expressions in your transformations, it becomes second nature. Also, there's no harm in having a cheat sheet with common GREL expressions nearby. And I often have to consult documentation from OpenRefined, and there's a lot of great resources on the OpenRefine website, as well as resources created by libraries online that could help you. So the first transformation, we're going to add that P to the accession number. So the way to add something is quite simple. Again, you'll see this is not difficult language. You just press the plus button. Now I'm going to stop there because I want you to see that parsing error that's in red to the right of the expression box. Now, obviously in this case, it's because the error is that I just haven't finished writing the expression. But at any point when you are doing your expression, if this pops up, then you might need to kind of reassess what you're doing. Otherwise, you're not going to actually be able to transform anything. And so we want to add a P. I'm going to just add a P, and then you'll see in that right-hand column that nothing is coming up, that the cells are null. And the reason why that is because this is a string of information, and we need to, in order to add to the string, it needs to be in quotations. So you'll see there. Now in the right-hand corner, this is exactly what we are looking for. So that is a really simple use of grow. I'm going to press OK, and now you'll see those options right there, and it's been cleaned up. So just like you can add characters, you also have the ability to replace characters, and this can happen in two main ways. One is, I'm just going to double check something here. Just give me a second. Okay, yeah. So when we joined those multi-cell values, we used the pipe to separate the values. Now, when we export this data and import it into our Atom instance, we don't want it to be shown with that pipe there. It's just not very attractive. What we do want is to create a new space. So there'll be two lines for the two descriptions. And one way of doing that is just by going to edit cells and going to replace. And so this looks very familiar. It's very much like the find and replace in Excel. It will only work within the selected column or the selected values within a column. So you have the opportunity to select where the case, whether the case is insensitive, you can use regular expressions. We want to replace the pipe, so I'm just going to add that there. And because we want to add a new space, you just can't type in new space. We're going to use a regular expression. So we're going to click here to allow for regular expressions to be used. And the regular expression for a new line is simply the backslash and then N. So we're going to press OK. And again, it's kind of hard to show you the changes that we've made. I don't know why I keep using the physical description because it's so many options, but you're just going to have to trust me on that. But using that format, you can see that you don't know what it will look like. And so maybe that's not always the way that you want to replace data within your columns. So another way of replacing data is using that transformation box that we had opened earlier to add characters. So we're going to work within the name access points for this. So I'm just going to let you know that there is a rogue subject in this name access point column, and it doesn't need to be there. And so I'm going to remove some of these. And that I already know because I was analyzing it earlier on, and I know that it is moderators, which is the term for the head of the Church of the United Church. So you'll see here, it's United Church of Canada moderators. So the subject is also the same. So there was some sort of error here. So we're just going to empty the subject column because we don't need to have all those name access points. And to do that, we can just go to the transformation box and then type into quotations. We don't want to have anything in there. If we put a space, then it's going to show a space. So for instance, and we're just kind of removing the value completely. There you go. So now it's all clear. I hope that makes sense. So what we actually want to do is just put moderators. We're not going to put the United Church. And then we'll apply to all, and then voila, it's all there. So now we want to remove every instance of this from the name access points. And to do that, we're going to go to the transform. So in GROW, which is the expression language we're using, to replace its value dot replace. And then you need to define what needs to be replaced. So that's going to be done in parentheses right after replace. Because we're working with strings, we're going to put everything in quotations. The quote we're going to copy and paste United Church of Canada, blah, blah, blah. And we're going to close that with a quotation. And then we're going to separate it. So that's going to be what is going to be replaced. We add a comma, and then we're going to do that two quotations again to remove it. And you can see here that now the instances where the moderator subject is in the names is no longer there. And so then we can just click OK. So you can also double check if you wanted to filter by moderator and see if it's there or not. Okay, so thank you for your patience. I know this is a lot of information. So another thing that we've been doing is just working on the cells data, but you can also modify and edit the columns. So I'm just going to scroll over here for a second. You can manipulate columns within the data set. So first you can move columns around quite easily by going to edit column. You scroll down here, you can move the column to the beginning and then to the end. You can move it to the left and move it to, move it to the right. And that's a lot easier than cutting and pasting. Also under edit column, you can rename or even just remove the column if you don't need it anymore. So for this demonstration, I want to combine two columns. And so in our instance of Adam at the United Church of Canada, we want the accession number and the item number to be a single identifier. And so we need to combine these. And to do that, it's pretty simple. You go to edit column, go to join columns, and then you have the opportunity to select what columns you want to join. You also have the opportunity if you want to create a separator. So you might want to put a space, you might want to create a new line, or in our case, we like to separate it with a /. So we're going to press OK. And then you can see here now that they have been cleaned up, and this is how we want our identifiers to look. There's also the opportunity to separate columns. And I'm going to go over here to the notes field. So I mentioned earlier on that one of a useful way of using OpenRefine is to separate information within a column so that we can, and in this instance, we can separate different notes into specific note entities. So our old software used to separate different lines of text within the notes field with a pipe. So you can see here, there's a pipe there. We actually want to kind of separate it all so that we're looking at less data within one column. And to do that, you can go to edit column and then split into several columns. We want to make sure that anything that has a pipe is separated, but you could also split columns by the field lengths, which might be useful if you're working with identifiers or call numbers or other other text, I guess. So then we just have to press OK. And then you'll see here that it actually created 5 different no fields. And so now you're working with kind of more manageable data that can be added to specific note fields for the different notes. We can also, I know, for instance, that there is a lot of notes in the first column that deal with how titles were formed. Oops. So you got 323 of those. Um, I know also by reviewing this before that it's all source of title information, which is a note field in rules for archival description. So I want that to just all go straight into a new column. So to do that, I'm going to create a new column based on this column. I'm going to call it source of title note. And we don't want it to do anything to the value. We want it to be exactly how it was. And then you press OK. And so you'll see here that a new title, a new column has been formed. Now we want to get rid of this. So again, we go here, we go to transform, and we remove those items. And so there's no longer title in that note. Um, so that is a nifty way of kind of dealing with a lot of data within certain columns. So we've covered a lot of information today. But there's one final function that I just wanted to quickly highlight, and that is the entity reconciliations. So OpenRefine offers the opportunity to match names, places, and subjects or other terms against external authority sources, so including Wikidata. By reconciling your data, you can standardize names, distinguish between entities with the same name. You can pull in additional information about people or places. You can create linked data by giving records persistent identifiers like Wikidata queue numbers. And if you're reconciling, you can also pull the URL for the term from the authority service and add it to your data set. So the actual process of reconciling values can take some time, which I don't think we have today. So unfortunately, we won't go through the process step by step, but I'm just going to show you where you can go. So I'm going to go back to places here. Um, and I'm going to go down here to in the menu to reconcile. And I'm going to start reconciling. You have an opportunity to select some saved services that you may have used in the past. Wikidata is always kind of the default um, service. So you can collect one of these, or you can actually go down here, add a standard service, or you can discover services from within this this page. Sorry, I kind of did that really quickly. In this case, we're going to pick Wikidata and we're going to select next. So it's going to take a while here. So it's kind of analyzing the different terms within the column and trying to figure out the different entities that may exist. So this is what I was worried about. Oh, it actually happened much faster than I thought. So you can select city. Let's for even though some of the places may be others, you can only select one at a time. So sometimes you might need to then change your matches later. So all you have to do after that is you start reconciling. Um, and so what I do recommend, I'm not going to press this because it will take a long time. So what I recommend is that before starting a reconciliation, you might want to copy that column and its values so you can still have the original to refer to. So reconciling will add matches that they have found within Wikidata or another service and add it to that column. And so you may need to cross-reference with the original terms. So in all honesty, I have not used reconciliations in my archival work, but I've played around and there are a lot of great opportunities to build upon your archival descriptions. So that really concludes this introduction to OpenRefine. I hope you have enjoyed the presentation and discovered some useful techniques along the way. If nothing else, I hope you will now consider using OpenRefine, that it will be in your toolkit, and that you'll consider using it the next time you need to clean or transform data. I'm just going to stop sharing my screen. Thank you, everyone.
Thank you, Erin. I really appreciate you sharing with us today and us having this introduction. So I don't see any questions yet in the Q&A. I know we had a few comments. Mostly everyone's now saying thank you.
There are 4 questions in there, Sarah.
Okay, let me open it up again because I just looked at it and I didn't see any. I'm just seeing a blank screen that says welcome to Q&A. Am I not in the right spot?
Okay, I'll read the question, Sarah. The first question says, hi, I used OpenRefine for a project in 2018, which I presented about at the SAA Research Forum that year, but I haven't used it in many years. How has it changed in recent years?
That's a really good question. So right before I started this working on getting information for this presentation, I had some key ideas of what I wanted to talk about. And then when I went to go search for it in the new version of OpenRefined, those transformations that I had currently used were not there exactly as I had remember. But I think there's been a lot of work done on the reconciliation work and increasing the services. Like I mentioned, there's integrations with MarcEdit now, so you can pull things straight from the MarcEdit and not have to worry about some of those extra steps of converting. But I mean, it's really just it's improving on a regular basis on making sure things are intuitive. There's less things now, I think, that rely on regular expressions or growl. And so that's great, especially for users that are not necessarily comfortable with scripting language.
Thank you. Sarah, can you see it now?
Yeah, I can. So it says we have a question. Is it possible to use OpenRefine to convert a PDF inventory into a spreadsheet?
So what I understand is that you can actually import a PDF straight. So if you were to convert that to text, then you can use that text within just one column within the OpenRefine, and then you can start using facets or filters to kind of review the content and and edit the data that way. So I know, for instance, people that were doing digitization work that have used OpenRefine, where they've taken the OCR, which we know can be problematic, and then using OpenRefine to identify common errors that occur within the OCR process. So that's a great way of using it. It's a bit of a different way. It's really more about filtering terms that you see and then doing kind of those batch transformations on those specific errors.
The next one is, how do you go from OpenRefine back into something like A2M?
Oh, so basically, because we're working with columns, what I do, so for instance, is I start to arrange a CSV according to the templates that are used for Atom. And so you can download those templates from Access to Memory website. And then you just kind of start moving the data to fill into those terms. So sometimes it's just a matter of renaming a title. So for instance, I can't think of it now off the top of my head. But like for instance, accession, we wouldn't be calling it accession, we would be calling it identifier. So you just change the title, make the changes that are necessary. And then once you've kind of cleaned it up and made sure that it's in the order of the template for Atom, then you can just export that. And I realize now that I didn't show you how to do that. But within the main page at the top, there is an export function, and then you can export it into a CSV. or to any other file format. But for Atom, for sure, they use CSVs, and then it's just a matter of then uploading it into to Atom.
Does OpenRefine auto-update if you edit a file outside of the program, or do you always need to upload the latest version of a file?
Yeah, so basically you're working with just within OpenRefine because you're actually working within that new file. It's not the original file. And so I might be wrong with this. There may be some great options out there and I just don't know about it. But my understanding is that you're working within that format, that saved OpenRefine file that includes all the history and everything else. Once you export that and then you start using it, you would then have to re-import the newer version if it was edited outside of the OpenRefine environment. Now, if there's anybody on the call that can tell me otherwise, that'd be great, but I don't think that's an option at this point.
And then the final question that we have is, with the cluster function, what do the different keying options represent?
So that is, I actually don't know. There's different definitions. And as I mentioned in OpenRefine documentation, it lists all the different clustering options, and then it tells you the parameters in which they are trying to find matches. So some matches might be like more specific characters are used. Others might be kind of more related to, size of a string. So again, it's incredibly detailed, and that is available on the OpenRefine documentation page.
Okay, well, it doesn't look like we have any more questions in the Q&A that I'm seeing. Is that right, Mary Grace?
Yes, yeah, you saw them all now, so that's great.
Yeah. Okay, great. Well, thank you so much, Erin. I really appreciate you doing this. And as we said at the beginning, a recording should be available on our YouTube channel in about 2 weeks.
Great. Thank you so much, everyone. And
All right,
please download OpenRefine if you haven't already.